Let's look at number 47 from the pre-cal book. This is the personal finance problem. This person's putting $25 in an account, and you have to be careful. The interest rate is 2.4%, but it's being compounded monthly. So basically for each compounding period, that 2.4 is getting divided by 2. So that's 0.024. You're dividing that by 12. And so you're going to get 0.002. You're going to get 0.2% of interest basically for every interest period that goes by. And over the course of 12 months, it adds up to 2.4%. So just in general, a person puts in 25, you can multiply by 1.002, and after 1 month goes by, that person's going to have $25.05. Okay. Part B for the question asks if she'll have enough money to buy. She's trying to buy a $750 computer. If she lets 2 years go by, will she have enough money? So you could keep multiplying by 1.002 and then adding another $25 and multiply by 1.02 and add another $25. You could keep doing that, or you could write a little computer program on your calculator to do that. That's not really what they had in mind here. So I've started listing values like at the end of each month, and kind of weirdly, I assumed that it would be an arithmetic sequence or geometric sequence or something like that, and I wasn't seeing it. So again, I went and looked at the solution. The solution, of course, it's a geometric series, and I thought, well, how's that happening? Here's how it's happening. Think about the money that the person puts in each month, okay? In the 24th month, the person puts in $25, and that $25 will get 2% interest, okay? So in the last month, the person puts in $25, that gets multiplied by 1.002. Okay, that's month 24. Okay, in month 23, he put in $25. It got multiplied by 1.002 in month 23 and in month 24. So that $25 got multiplied by 1.002 to the second power. Okay, the money that was put in the month before that was $25, and it got multiplied by 1.002 3 times. And this is going to continue all the way back to the original money, which was put in, and it got multiplied by 1.002 24 times monthly over the course of 2 years. And so if you set it up like that, this is a geometric series because you're multiplying by 1.002, multiplying by 1.002, and so on. So what do we have here? Our initial value is 25 times 1.002. So A sub 1 is 25.05. Okay, our R value is 1.002, and so you can just sub this into the sum formula. It's going to be A sub 1 times 1 minus the common ratio to the n power. Okay, this is going to be 24 pay periods all over 1 minus n. And anyway, if you work that out, oh, I had it on my calculator, I don't now. Let's see, 25.05 times 1 minus 1.002 to the 24th power, close parentheses, divided by negative 0.002. Okay, and we get $615.23. So the answer here is, nuh-uh, this person's not going to have enough money to buy a computer. Okay, now the follow-up question was, if the person needs to know how much to invest to get to $750, what would that total need to be? Okay, so my thought was, that needs to be a variable, right? This stuff's all going to stay the same. And so I want this to be a variable. I'll call that A sub 1, and we want this to work out to be $750. Anyway, you can evaluate all of this. 1 minus 1.002 to the 24th power divided by negative 0.002. Okay, so 750 is going to be equal to A sub 1 times 24.560, blah, 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 blah. I'm going to keep that in my calculator, okay? We can divide both sides by that value, and we have to be careful here because, so 750 divided by the answer that I got there is going to end up being about 30, A sub 1 is going to be about 30.537. But be careful, that's at the end of the first month. That's after it's already been multiplied by 1.002. So you're going to have to divide that by 1.002 to undo that original interest. And as a result, it's about $30.48 ends up being the amount that this person's going to have to put in monthly to get to $750 by the end of 2 years.